We're going to be talking about our third way of solving a system of equations, and that's going to be by elimination. Now, elimination is typically the one that most students prefer. All right, and it actually uses substitution. So even though some people don't like substitution, they love elimination. It's super weird, but it works. All right, so let's go ahead and set up our notes. And it's going to be going to the bottom, and you're going to be folding the bottom to the top right here. There's a kind of a line, and that top part to the middle, kind of bottomish. And the first thing we're going to do is we're going to open this flap down here because it talks about how to use elimination. All right, now the first thing you're going to do is you're going to write both equations in standard form. Ax plus by equals c. If it doesn't meet the requirements, like your a value is a negative, it's okay. In this case, in elimination, we're going to break the rules a little bit, and it's okay, right? If needed, you're going to have to multiply equations by an integer to create a zero pair with the variable. Remember when we've been saying it's going to zero out? It's to get you ready for this moment right here. You're ready. All right, then you are going to either add or combine the equations together. One of these variables will be eliminated. And hint, you want to stack the equations. And that's how I'm going to show you how to work it today. You want to solve to find the first coordinate pair. And just like in substitution, this last step is going to be the same. Okay? And what you're going to do is you're going to plug that answer, that first coordinate pair, into one of the original equations. And this time you can pick, hint, always pick the easy one. Work smarter, not harder. And you're going to plug it in for the second half of your coordinate pair of x, y. Remember, a solution is a point. So it's x, y. You need both variables. You need a number for both. All right, I'm going to go ahead and keep these steps open for us. I know you guys have a little bit more room to work with it, and I'm working long ways. But notice how I write my work, all right? I'm keeping it neat. I'm keeping it line by line. I am also going to be color coding it. You don't have to, but it does help. If you want to use a highlighter for anything we substitute, you can do that as well. All right, your first example, write both equations in standard form. Well, that's done. And I know this one has a negative a. Shh, we're going to ignore it for now. And these first three examples, we're not going to need to do this really. All we're going to be doing is stacking first. So let's stack it. Hey, look, it's already stacked. And now what you're going to be doing is you're pretty much adding each and every one of these to get a brand new equation. You get 8 plus 4 is going to equal 12. Negative 6y plus 2y is going to be a negative 4y. Negative 5x plus 5x, that's our zero pair because negative 5 plus 5 is a 0. So that entire thing zeroes out. And you're only left with negative 4y equals 12. All right, now you have to solve for y. So you're going to divide by negative 4, and you get y equals negative 3. You've got half of your coordinate pair already. That's how easy that was. You're going to take this number now and substitute it into either one of the two equations. I am going to be showing it to you with both. You pick whichever one you want. All right? Remember, I always recommend you write the equation you're using first, which is what I'm doing here. And then our y is equal to negative 3. So we're going to substitute it in. Remember, if you're doing this one, your first equation, stick with that one. If you're doing the second, stick with that one. All right, so you substituted the negative 3 in. You simplify it. Then you move that constant over. Divide by the coefficient. And then you get x equals 2. So you'll notice no matter which way I took, you still got the same answer, which was x is 2. And this entire thing right here is your boxed answer. That's your solution. That's where both of these lines, when graphed, would intersect. Let's try another one. All right. Well, if we're looking at it right away, remember, we're not looking at step 2 this time yet. If we're looking at it, our y's are going to zero out right away. I can zero it out, don't care. So then I'm going to just add down this way. And I get 3x equals 15. You'll notice I just kind of squeeze that over to the equal sign. They like to be cuddly along that equal sign. It's okay. All right, then we're going to divide by 3, which gets us x equals 5. That is the first part of your coordinate pair. Now you have to come back and drop it into either one of these original two equations. Remember, you pick one of them, not both. Work smarter, not harder. It'll work regardless. Now, based upon whichever equation you used, you're going to substitute that y in, or I'm sorry, that x in this time. X equals 5. Simplify. Move your constant over. Divide by your coefficient, and you get the same answer no matter what, which is y is equal to 4. Right? You can do this. Remember, pick one of them and pick the one that you like better. You don't have to pick the first one. You don't have to pick the second one, but you do have to pick one of them. Oh man. So as we're looking at this one, there isn't a zero pair. But notice they both have the coefficient, the same coefficient on our y's. It's got the same big B value. We need one of them to be negative. And I typically like doing my second one. It just kind of depends. If we just turned all of the signs negative on that second one, just flipped all the signs, that would work for us. And in fact, look what happens now. When we add down, that 3y and that negative 3y now zero out. And you get 4x minus 5x and 2 plus 2. So you get negative x equals 4. Well, you're looking for a positive x. And if negative x is positive 4, positive x is going to be negative 4. So we've got half of our coordinate pair. We're going to take that coordinate pair, drop it into one of the two equations, pick the one that you like the best, drop it in for your x, because that's what it told us it was. Simplify, move your constant, divide by your coefficient. You've got your y variable. And you've got your solution for the entire intersection. Now, you did that, and in this step, you technically kind of did do number 2, but we're going to get a little crazy with it. So open up your next flap, where we're going to have to multiply to make sure that both of these match up. So let's look at example 4. And this one, you can multiply by either the 3 or the 2 to get that zero pair out. And it's because you want to look for opposite signs. This is a positive, this is a negative, negative and positive. So either one of them are good candidates, and you're going to multiply it so that they both have the same coefficient. We only have to multiply that bottom equation this time. I'm going to multiply it by 3 so I can just get rid of the x's. Because guys, we don't need to keep thinking about our x's, okay? So when we do that, you're going to get a brand new equation. I'm going to rewrite my first one right after this, so it'll help me stack it better. And when I distributed out this 3 to each of them, I got negative 3x plus 3y equals 3. I'm going to bring my original equation back down so I can stack it, just like right here for step number 3, and I can get ready to get rid of my zero pair. And you'll see that my zero pair are my x's in this case. Then add on down 3 minus 2 and 3 plus 3. This one was super easy when it ended up working out that way. And you got y equals 6. Done. Well, not quite. You remember steps 4 and 5? Where you have to plug it in to find the other half of your coordinate pair? Yeah, you still have to do that. So pick, again, whichever one of the two original equations. Personally, I picked this one because that looks so much easier to work with than all of these numbers right here. So Let's drop that number in. We've got negative x plus 6 equals 1. That's the one I'm picking with. If you pick that first equation, totally okay. Follow along and watch my steps. Distribute that out, and on the right side, it's so much easier. Move your constant over, divide by your coefficient, and you get the same answer of x equals 5. And you'll notice this work right here was so much easier to work with than that one. And you might be like, no, Miss Samji, the blue one was easier for me. Great, use that one. Use what works for your brain so that you can get the right answer. Unlike me, who wrote the wrong answer there, right? So your answer will be 5, 6, and that is your intersection or the solution of those two lines. If you ever get like a no solution or all real numbers, by the way, which you'll be able to figure out, then you can figure out that it's a no solution, hello, or an infinite solution. All right, we got 2 more examples. We can do this. This next one, we are not only going to multiply it by a number, but we're also going to flip the signs because look at this 5y and that 10. We know we can double it, but we also need opposite signs, and right now they're both positive. So we're going to multiply that top equation by a negative 2. All right, so now it's going to be negative 4x minus 10y is equal to negative 6. That's what equation we're going to work with to use our elimination. Get our zero pair of our y's. And we get negative x is equal to negative 9. Well, we're looking for positive x, which means it's going to be a positive 9. Take that and drop it into one of the 2 equations. Honestly, in this case, it kind of really doesn't matter which one you go with. If you don't like negatives, you might pick the first one. If you're like, negatives don't bother me, you might pick the second one. Do the one that works for you. Plug it in, simplify, move your constant, divide by your coefficient, and you've got your y value of negative 3. And that means you've got your solution of 9, negative 3. So at 9, negative 3 somewhere, these 2 lines are intersecting. And I don't know what they look like. Maybe like this. I don't know. They might both look like this. But that's what's really happening here with that solution. Uh-oh. Right away, you see, well, you see opposite signs on this one. But like, no matter what, I can't multiply just one of them to get it to work. Guess what? You're going to have to multiply both of them this time. So I am going to use this one right here because I like the number 10. 10 is easier to work with than whatever that 12 would have gotten us. So I'm going to multiply that top equation by 2 and that bottom equation by a negative 5 so I can flip the sign of this bottom one. I like my bottom one to be negative so I can, it makes it easier for me. You do what works best for you. If you were to multiply each of these by negative 3 and then 4 respectively, that would work as well. This is one way of doing it. All right, so the first equation, when you multiply it by 2, you get 8x plus 10y equals 70, because that's 2 times 35. Then you're going to multiply that negative 5 to each of these 3, and you get 15x minus 10y equals 45. Now that they're stacked, you can combine it all together, and that's where, by the way, the other name for elimination comes in, linear combination, because you're combining 2 lines. And you're going to get a zero pair right here. And you get 23x equals 115. And your brain just went, I don't know what that is. Guys, you get to use a calculator. So pull out your calculator, do 115 divided by 23, and you get x equals 5. It's your x value. Take that, plug it in, and find your y value. Use either one of these 2 equations. And I want you to stop the video here, do it on your own, and then come back and check it. All right, now that you've gone and checked it, you're going to substitute it in. No matter which equation you use, you must use the original one, not any of these funky ones that we created. Make your life easier. All right, so I am not substituting the right number in right here. So I got 4 times 5 plus 5y equals 35 over there. All right, simplify it out, move your constant over, divide by your coefficient, and then you've got your second coordinate, which gets you y equals 3, and you've got your entire solution of 5, 3. You just made it. All right, that is the third way of doing it. So think about it. When they're both in standard form, it's a whole lot easier to use elimination than when we were working with substitution, because that's gross. All right, so both in standard form, use elimination. Thanks for watching.